So, very good evening, guys. Welcome to the third class of carbohydrate chemistry. Today the topic is reactions of carbohydrate. Let us come to the first slide. What is the dehydration of a monosaccharide? That is the removal of water when heated with acids. It produces furfural from pentoses and hydroxymethyl furfural from hexoses. Okay, and this from the basis of Mollis test. So, when any kind of carbohydrate heated with H2SO4, that gives rise to this furfural. This furfural with presence of alpha naphthol gives rise to a specific color that is used for primary identification of that carbohydrate. Coming to the next slide. So, Mollis test is based on this principle. So, it is used for identification of any carbohydrate molecule, whether it is an oligosaccharide, disaccharide, polysaccharide, anything. Coming to the next slide. So, look over here. This is the D-ribose. It is the 5 carbon ring 1, 2, 3, 4 and 5. So, D-ribose, it is a 5-member ring with the addition of concentrated H2SO4 gives rise to these furfural derivatives with liberation of this molecule, 3 molecule of H2O, and this is a D-glucose. In addition of H2SO4, it gives rise to 5 hydroxymethyl furfural derivative. So, with furfural derivative, it forms a purple or violet color condensed product. Tautomerisation. Tautomerisation stands for the conversion between aldehyde and ketone form. So we can see over here that this is the aldehyde form and this is the ketone form. So conversion between aldehyde and ketone forms, it is known as the tautomerisation. It happens in the alkaline medium, glucose, with the conversion of fructose. Let us the next slide, that is, look at this slide. Glucose, that is the enediol formation. It forms 1,2-enediol, that is the intermediary in an alkaline medium with simultaneous formation of the fructose. So you can see over here, this is the carbon number 1, 2, 3, 4, 5 and 6. This carbon number 1 and 2, it contains 2 OH group. So it is the 1,2-enediol form. There is the intermediary product. Coming to the next slide. So oxidation reaction, you can see over here, oxidation reaction, aldehyde group lead to formation of acid. COOH. Mild oxidation lead to production of glucuronic acid. Strong oxidation, it is the glucaric acid. Basis of that forms the basis of Benedict and Fehling test. So it is an aldehyde group. Upon oxidation, it gives rise to COOH. Strong oxidation and mild oxidation. Coming to the next slide, that is, see over here. Here, it is a glucose. It gives rise to the glucuronic acid. This is the COOH group, stand over here, and it is the glucaric acid. This is the dicarboxylic acid. I have marked the dicarboxylic group here. So it is a mild oxidation. This is the strong oxidation. Okay. So COOH to 1 CHO to 1 COOH. It is the basic, and strong, there is formation of 2 COOH group. Coming to the next slide. Reduction reaction. When there is reduction, this aldehyde or ketone gives rise to alcohol. As you all know from the organic chemistry, this gives rise to the alcohol. And glucose gives rise to sorbitol and mannose gives rise to mannitol. So when there is plenty of glucose inside the cell, there is increased level of sorbitol. This sorbitol lead to osmotic changes in our viscera that gives rise to cataract and many other diseases. Coming to the next slide. Look over here. it is the D-glucose, and in presence of NaBH4 and CH3OH, it gives rise to D-glucitol. It gives rise to D-glucitol. This group is converted into this one. Coming to the next slide, amino sugar. Amino sugar means one OH is replaced with NH2 minus. Examine is glucosamine, found in chitin and GLAX. Found in chitin and GLAX. Coming to the next slide, this is the glucosamine, this is the galactosamine. This is the glucosamine and this is the galactosamine. So this is the structure of a glucose molecule when it is OH. Look, OH has been replaced with NH2. So this is a glucosamine and this is the structure of galactose. So this OH group has been replaced by this NH2. So it is the galactosamine. Coming to the next slide, deoxy sugar. Deoxy, as the name itself suggests, that one oxygen molecule has been removed. So it is a deoxy sugar. When it is ribose, it is called the deoxyribose. Deoxyribose is an important component of DNA, and deoxyribose is also less reactive than the normal sugar. Less reactive than the normal sugar. This forms the basis of why DNA is much more stable, because the presence of deoxyribose. So DNA increase stability by deoxyribose. Coming to the next slide, so it is the ribose and it is the deoxyribose. You can see over here the number of carbon molecule for 1, 2, 3, 4 and 5. So this is the ribose and this is the deoxyribose. Coming to the next slide, esterification. So OH group react with acid, form sugar ester. Example is the phosphate ester in metabolism. So you can see over here, this is the molecule, sugar molecule. It is a fatty acid, is immobilized phase, gives rise to the sugar ester. You have to focus over here, this region. You have to focus this region. Okay, and there is H2O. Coming to the next slide, glycoside formation. Glycoside formation there is lead to formation of the glycoside by addition of sugar and alcohol. Occurs in the aromatic carbon and non-reducing component. Coming to the next slide, this is the glucose, this is the fructose. Okay, so you can see over here, this is the sucrose. Look over here, this is the glycosidic linkage. The glycosidic linkage contains 1 and 2. So in the 1 and 2 there is blockage of all the functional group in sucrose. Blockage of all functional group. There is no functional group. That's why sucrose can't participate in many reduction reactions like Benedict reaction or Fehling reaction. In this blockage explains why sucrose is a non-reducing sugar. Okay, coming to the next slide, Osazone formation. Sugar plus phenylhydrazine lead to formation of the Osazone crystal. Glucose, fructose, mannose, almost approximately same type of Osazone. This Osazone test usually used to identify the sugars. In OSPI table in laboratory, you may have to identify the Osazone. Okay, so OSPI, it is very important. OSPI stations, it is very important. Coming to the next slide, have a look about the Osazone crystal. So it is the needle shaped crystal. You can see over here, this is the needle shaped crystal. This kind of crystal, it is a glucosazone crystal. This is a sunflower shape appearance. This is a maltosazone crystal. This is the galactosazone crystal. It is a galactosazone crystal, rhombic plates and powder puff appearance. It is a powder puff appearance. It's a powder puff of appearance. It is the crystal of lactose. It is the crystal of lactose. Commonly lactose or glucose is given. Commonly lactose or glucose may be given in your exam. One more important thing, how to differentiate glucose from the galactose. How to differentiate glucose from the galactose. Sometimes there may be a look-alike crystal. So for this separation, you can use mucic acid test. Apart from that, you can use chromatography. You can use X-ray crystallography. This can be used to identify any structurally different component. Okay. Also, you can use NMR spectroscopy to identify glucose from galactose. Okay. So thank you so much for watching. I will be sharing all the core textbook chapters into this kind of PPT format. It will be easier for you for helping. After that, I will also share some revision notes over here. This channel is for everyone who want to learn the biochemistry in an easy format. Please like, comment, share and subscribe the channel and support me to make new videos for you. Thank you so much. Thank you.